Okay, so we're still working in section 9.1 in your textbook, and now we're going to finish talking about it. So what we want to talk about is maybe how many answers there are to these nth root problems. So let's talk about it in terms of some different numbers. So we have positive real numbers. So we're going to go with positive numbers over here. We have negative numbers. And then we also have the special number 0. So 0 is neither positive nor negative, so we give it its own category. So we're going to talk about some different things. So remember, we're talking about nth roots. So we're talking about x to the n equaling k. So when n is even, so example n is 2, 4, 6, whatever, you're going to have two answers. You're going to have one positive and one negative answer. So for the example, we could say x squared equaling 4. So my n here is 2, and I want to know what number squared equals 4. Well, 2 squared is equal to 4, but negative 2 squared is also equal to 4. So my two answers are 2 and negative 2. So basically a plus or a minus an answer. If your n is odd, so for example 3, 5, 7, and so on, you only have one answer. So for example, if I wanted to say x cubed is equal to 8, the only number that does that is 2 cubed. So only 2 cubed will equal 8, so then my answer there is just the 2. If I have a negative number, so let's say when n is even again, so again we have powers like 2, 4, 6, 8, so on, we are going to have no answers. So for example, if I have x squared equaling negative 4, well, no real number squared is going to give you a negative number, because anything squared, anything times itself, becomes a positive number. So for instance, if I do negative 2 times negative 2, well, that's positive 4. So there are no solutions, at least in the real numbers. If we were talking about imaginary numbers, it would be a different story. So then if we have n is odd, so we have odd powers like 3, 5, 7, and so forth, I can say, okay, you have one answer. And that answer is going to be like, for example, if I have x cubed, so there's my n is odd, is equal to negative 8, well, negative 2 will work for that. So you might be saying, why does that work? So let's think about it written out. So a cubed power means multiplied by itself 3 times. So I have negative 2 times negative 2 times negative 2. Well, the first 2 will give me a positive 4 times another negative 2 will give me the negative 8 back. So here my answer is negative 2, and it's the only one. So 0 is a special number, and 0 only has one nth root. So it doesn't matter what n is, n can be even, odd, whatever, only has one answer. So for example, if I have x to the 4th equals 0, well, the only answer for x is 0. If I have x cubed is equal to 0, well, the only number times itself 3 times is going to be 0 again. So it doesn't matter what type of power you have, if it's bigger than 1, the answer is 0 every single time. So then we also want to talk about what a radical symbol is. So hopefully from pre-algebra, algebra 1, algebra 2, geometry, everything up until now, we've talked about it already before, you know that this is called a radical. So the formal name for it is a radicand. And so we don't just have to use it with square roots. So this is your symbol for regular square roots, but we can also have a cube root. We can have a 4th root, and so on. Like, it doesn't matter. You can put any number out there for the power. So our formal definition for this is that n has to be greater than or equal to 2 and a whole number. So it can be 2, 3, 4, 5, anything like that, but you can't have like 2.5. So the number that we put on this outside, this is the n that goes on the outside, and this n is called the index of your radicand, of your radical. So it basically tells you what root you're dealing with. So the rest of our definition goes is when our x is greater than or equal to 0. So it has to be 0 or a positive number. The positive root of x, the positive nth root of x can be written as this. So that's just the positive one. And we already just talked about that in our previous video that you can also write this as x to the 1 over n. This is the same thing. So that's when x is positive or 0. So what about when x is negative? So when x is less than 0. So then you have x is less than 0, and you have to have n is odd. You can only do this with when n is odd, because we just talked about on the previous slide that if n is even, if we go back, if n is even, there are no answers, so this isn't going to work. So we can only talk about the odd case. You can say the real nth root of x is, again, the square root symbol, the radicand with n outside as your index. So maybe we want to talk about what that means. So that's basically just another way of doing our problem. So before, our examples were, for instance, we wanted to do, in our last video, we did 125 to the 1/3 power. Okay, well that's just telling me, if I rewrite this in the way we were just talking about with the radical symbol, my exponent here, this is my n, this is my index. So that 3 is going to go outside, and then I know that that is 125. And maybe that's a little bit more familiar, or you know how to type that into a calculator and get that the cube root of 125 is 5. So it's the same thing as the answer that we were previously getting. So that was an example of when n is odd. So then let's do another example of when n is even, or we have an actual, let's do a negative example. So we want to do, let's see, we got negative 32 to the 1/5 power. So we're going to rewrite that using our root. So again, the 5 is the n, so we're going to do the 5th root of negative 32. And so I know that when my number is negative and n is odd, like 5 is, I'm only going to get one answer, and it's going to be negative. So I want to think about what number to the 5th power is going to give me negative 32, and that is negative 2, just going through our list. Like 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, so 2 to the 5th is 32. And since I have a negative number under my radicand, my answer is going to be negative. So there's another example of how you can do radicals with nth roots.